immeasurably. So thanks very much for the invitation. The title of my talk is here, How Ovarian Aging Can Modify Chronological Aging. And my collaborator, Sean Lowley at the University of Utah, his email address is included in case people would like to reach out to deal with some of the harder math issues in the project. I have nothing to disclose. This is more of a clinical slide. And so I'll be talking about general concepts in ovarian aging and try to, to convey some lessons about how the ovary works, both well-known and some recent insights we've added to the field. I'll talk about how we're able to simulate the behavior of the primordial follicle reserve in the human ovary and how that actually recapitulates patterns of landmarks that their timing in women, the menopausal transition and age of natural menopause. We also can model the impact of interventions, whether positive or negative, and this is consistent with what we saw this morning. I'll talk, I think the reason you're in this room is you'd like to know about interactions between reproductive ovarian aging and chronological aging, and there's a lot of interest in treating and delaying menopause with the goal of delaying or increasing health span and increasing lifespan. That's why I'm here. How might slowing ovarian aging influence overall chronological aging? What's the potential of improving the parameters? This meeting is designed to address the major question in ovarian aging, if you'd like to target the ovaries and slow their loss of follicles, is who would benefit from this? Women don't reach menopause at the same time currently. They reach menopause about 20 years apart. The beginning, if you believe that the clinical definition of early loss of ovarian function of age 40 is a hard limit, and that's the earliest. Women surely reach menopause earlier than that. They could benefit from treatment, but would a woman who is going to reach menopause at age 60 benefit from the same treatment? They're the women, I'll show you, who are currently most likely to live the longest. My lab deals with, we're the wet lab data lab. Sean Lowley and Jay Emerson at Yale are the mathematicians. We like to think this is a virtuous circle in our interactions that can lead to mechanistic insights about how the ovary works and maybe clinical actions. And here, can we take those clinical actions and modify lifespan or health span? Busy slide. The highlighted words are what you need to take away. The definition of the age of natural menopause is when menstrual cycles cease for 12 months. The earlier menopausal transition occurs in this long definition, although it's interesting, at least 7 days difference in the length of consecutive menstrual cycles, where 7-day differences occur within 10 cycles. And all of those words, you say, well, there must be a simpler way to measure when menstrual cycles become irregular, but it turns out you have to choose a way, and this is the way the field has chosen. About 1 in 250 women will experience menopause, the cessation of ovarian function for a year prior to age 35, 1 in 100 before age 40. The clinical term for that is premature ovarian insufficiency. This is very common. It's more common to have early menopause than the top 10 cancer incidents combined, so this is impacting lots of women. Again, cui bono, those are the women who would be likely to benefit from delaying their loss of ovarian function and potentially extending their life and health span. The top quote is from a paper with my boss, Dr. Nanette Santoro, some time ago, where we said that menopause is related to ovarian follicle depletion. No, that was a misstatement. Menopause depends causally upon ovarian follicle depletion. Losing your reserve of primordial follicles results in the loss of endocrine function of your organ. The aging landmarks that are mentioned relate to the fact that losing follicles to the point you can't support regular menstrual cycles leads to that menopausal transition, and then there's a point where you have no menstrual cycles, and that's menopause. I'll show you that the supply of growing follicles that comes from that reserve becomes increasingly limited and erratic, leading to these outcomes. A graphical way of looking at this is there are many, many primordial follicles, small blue circles at left. Girls can be born with up to 1.2 million or so. A subset of those per unit time will begin to grow, shown in blue and red, where red indicates the vast majority of follicles that will go on to die during the continuum of growth, leaving approximately 1 left each month that might ovulate. Overall, my lab is interested in this simple question: what determines the rate that individual primordial follicles will begin to grow out of the total. Why does one primordial follicle begin to grow at age 13, and another that was physically in contact with that structure not begin to grow till that woman is, say, 58? So that is how I got into this area. And in terms of some of the math, only less than 1% of follicles are ever relevant to reproduction. The rest that grow and survive are relevant to endocrine function. And the endocrine function comes from inside the green box, these larger follicles, antral and preovulatory follicles. Again, only one will ovulate or thereabouts per month. Considering the pattern of loss over time in the population, you can see the Kaplan-Meier curve at right. The distribution is around the median age 51 in women. This doesn't vary very much in ethnic groups around the world. And the trajectory of loss, if you look at the small letters here, these are the human landmarks. The larger lettering is mouse. So at the time, week 24, girls have approximately 7 million primordial follicles developing in their ovaries. This declines at the time of birth to that 1.2 million or thereabouts I mentioned. By puberty, it declines further, and reaching something like 1,000 remaining, and I'll get back to that at the age of menopause. So this morning we heard a lot about disease states, or in this case, health compromises. So what are the consequences of menopause, and how might these relate to the impacts of aging? So when you hit menopause, women will have cardiovascular changes, mostly seen in carotid artery thickening, bone density changes, body fat, and I won't continue to read the whole list, but there are lots of disease states or health and well-being compromises that begin with menopause, and the age that you hit menopause influences the symptoms, and the cohort study shown there suggests that if you had menopause at greater than or equal to 53 years, you had reduced frequency of certain symptoms, reduced and increased frequencies of others, hot flashes, for example. So both the timing that you reach menopause, the timing can modify the types of consequences of menopause. The symptoms, however, that I think this field needs to consider actually can occur earlier in the menopausal transition, the time when periods have become irregular. This is referred to as an occult event because you have to go 12 months without a menstrual period to reach it, so it's the preceding time up to that 12 months when periods are irregular that you're in this menopausal transition. Many of the symptoms discuss that people think of only beginning to occur at menopause actually begin to occur in the menopausal transition. So these include those listed in large text at bottom. And I'll highlight the differences in bone density. And so bone loss is an extremely significant consequence of reproductive aging in women. One of those that would lead to shorter lifespans, especially after risk of fracture. And so this begins in the earlier menopausal transition is really important for a general aging audience, right? We're not just talking about things that start at menopause, they're actually beginning in the earlier menopausal transition. If ovarian aging is a critical determinant of health, how about specific cardiovascular outcomes? You can see here from these papers, the earlier the menopause, there's significant risk, increased risk, moving leftwards of cardiovascular disease and stroke. So however, the question still remains, if you have menopause later, are you likely to live longer? And there is signal in the literature that that's true. That signal in the literature absolutely is leading to this churn in biotech and other laboratories where delaying ovarian aging should lead to longer life and improve health span. But this brand new paper, and I've been in touch with Dr. Kirby, the corresponding author of this work, does show that if you bin menopausal age at left into categories before 40 and then through above 55, you can look at the percentage of women who die prior to or after their centroid at age 84, and both with natural menopause and surgical menopause, the removal of ovaries, you can see that there's an increase in women who survive beyond that 84, the later they hit menopause. Linear regression at right in each case, natural and surgical, are shown as well. So indeed, having menopause later does correspond with a longer lifespan. Given that lifespan is expected to increase, this is a little dated. People may have a better picture of this than I do. If life expectancy continues to increase, you definitely would like to have menopause the latest so you can have even more benefit at the other end, we'd assume. So the concept here is delaying the consequences of all risk mortality of a female reproductive aging will lead to improved health and possibly lifespan. And I'm here to emphasize this does include the influence of the timing of the menopausal transition as well as menopause. I was happy yesterday to be around to hear a definition of the word geroprotective, because we can consider, given what I've told you so far, that ovaries are geroprotective prior to the menopausal transition. I'll tell you how I came up with that 2,000 primordial follicle number in a moment. But functional ovaries are geroprotective because they reduce or keep away these symptoms that are associated with poorer life expectancy. Importantly also, increasing numbers of women do have some advance warning. There's ways to understand what the remaining ovarian reserve is. Historically, this wasn't true. There'd be little warning that menopause would be earlier than anybody else. However, women today can receive a reproductive endocrine workup, have evaluations like antral follicle count or anti-Mullerian hormone measurements. That's a hormone produced by small growing follicles that we can indirectly estimate the number of remaining primordial follicles. So the risk of early onset menopause can be estimated. And so there are increasing numbers of women that we can identify at least as higher risk and who would benefit from some sort of intervention. I told you about who would benefit problem, and there is some ways to get at that. My lab works on how the identification of mechanisms that control the rate of primordial follicle loss during ovarian aging, and hopefully by understanding this process better, we can better identify those who will benefit and how they'll benefit. So at the end of my talk, I moved my wet lab slides, my bread and butter, what I would normally show as the evidence for the model. I'll summarize here due to time. But if we do have time, I'm happy to show you the wet lab data. But our model works as follows. Follicles in the ovary are experiencing cellular stress. We show that cellular stress activates the integrated stress response pathway. The integrated stress response pathway, once activated, prevents cells from growing. So high levels of stress correspond to non-growing cells, which really sounds a lot like dormant follicles, right, that aren't growing. In our model, an acute stress comes along, increasing integrated stress response activity. There's an overcorrection, and we see this overcorrection in lots of damage models, including the upregulation of DNA damage repair mechanisms. And in some cases, this stochastically leads to follicles overcoming the barrier or vertical dashed line threshold of growth. This is referred to as integrated stress response checkpoint resolution, and individual primordial follicles begin to grow. So this model, having come to this from wet lab studies, led to reaching out to each of these two gentlemen collaborators, Sean and Jay. I used to work with Jay at Yale. And just by luck, Sean turned out to be the perfect person to push the mathematical analysis forward. So we came up with this sort of general scheme for how randomness or stochastic conditions might influence primordial follicles. And if I just click back to this model, our inference here was that within the red zone, follicles can either be more or less stressed, so they're fluctuating within this continuum of stress, bringing them closer or farther away from growth activation. And so here's how this might occur physiologically. The same primordial follicle is included in the same position, and that follicle experiences regional changes in stress over time. Unlike most of our other organs, Ovaries are never the same physically. They're always changing. Follicles are always growing and dying, developing a corpus luteum. Blood vessels are growing to supply these structures and regressing as these structures die. So this is a very dynamic organ. And so beyond that, the dynamic changes that occur in real time, girls are born with different numbers of follicles. I hinted at this earlier. The distribution in different girls is approximately 300,000 at the low end to 1.2 million at the high end. And so we just asked the question, if we treat these different numbers of primordial follicles as if they're going a simple one-dimensional random walk, we can determine how the difference in starting number impacts the time of exhaustion, and exhaustion is down to that approximately 1,000 remaining that I said. Another way of depicting our black triangle model from earlier, flip it on its side, show that integrated stress response or any growth inhibitory pathway fluctuates, and over time monitor the action of a single primordial follicle. In the first case, it's fluctuations across the growth threshold at age, say, 21, another 36, and another at age 51. And so running that simulation of follicles treated as if they're undergoing random walks, we first showed that if you treat all individuals identically, that only vary by the number of follicles they're born with, 10 to the 5th to 10 to the 6th shown here. The dashed lines are trajectories of simulated follicle loss over time, and the red dots are actual numbers of follicles in human ovary specimens counted. So these lines are all parallel because the K curves are being controlled identically. We can introduce time invariant drift, making subjects vary from one another. So individuals here might start with a higher number of primordial follicles at birth, but their loss over time due to the random walk and random threshold crossing leads to their crossing, where this person with higher numbers reaches menopause earlier than someone born with lower numbers. We can also, simulate here what happens if chemotherapeutic treatment was received at age 12, or test whether the acceleration of follicle loss thought to occur due to declining levels of anti-Mullerian hormone, for example, is necessary. It turns out it's not necessary to get good curves, but it's useful for us to be able to simulate. So if you compile the results of simulations in the variable drift model, to quite a surprise to us, what you produce is a curve that goes right through the known timing of human menopause. And again, if you're an ovary person in the audience, this is surprising because you're modeling the behavior of follicles and getting the time distribution of this life event, right? And so what we still didn't know were two things: whether the 1,000 follicles left, that round number, is physiologically meaningful, and we also didn't in that first work have any sense of how this might relate to the onset of irregular menstrual cycles. So we went on and did the same sorts of analysis, and by modeling primordial fall action over time as undergoing a random walk. But what we stumbled into is, asking whether we could track the gaps in days that occur as follicles are running out, given their loss trajectory. When do the gaps begin where no follicles begin to grow? And what that would lead to is interrupted production of growing follicles needed for endocrine function, like I showed you earlier. So you can see the red line is the average number of days that occur without any growing follicles. When you're young, you have thousands of follicles and thousands beginning to grow every month. So no days pass without any primordial follicles begin to grow. However, mid-40s is the first time that in an individual simulation at left, that 7 days pass in this specific single simulation where none begin to grow, and the purple line is 12. These barcode plots at right, blue unbroken color indicates that there are no gaps of 7 days or fewer than 7 days that pass without a single primordial follicle beginning to grow. Girls born with the fewest and the most, lead to a greater time if you're born with more follicles that you have where there's no days where none begin to grow. And of course, the white gaps are gaps in growing follicles. The same 7 and 12 days are indicated by green and purple. Here again, compiling the result of simulations, you can see that the 7-day gaps match up quite well with the reported distribution of the onset of the menopausal transition. And again, 12-day gaps match up with age of natural menopause. Each of these, I can note, the data here are produced by women logging their menstrual cycle patterns, right? These are done, independently of biological measurements, and so, it was pretty exciting when we saw that the behavior of follicles, what's going on in the ovary, could produce these patterns. And I mentioned it's not clear that the round numbers of remaining follicles should be physiologically meaningful. And our contention is it's not the absolute number of remaining follicles, but it's the gaps in days required for follicles to be available and survive to keep the next menstrual cycle going. If you go more than 7 days and that becomes increasingly erratic, your cycles will become more erratic. After 12 days, when none show up in the growing pool, you can't keep cycles going. And so a better understanding of what individual women will reach these stages will allow us to actually understand who's like to benefit from different interventions, so that people who are interested in targeting ovarian aging as a way to increase lifespan will know who to treat. This paper came out recently, and I couldn't help but include it. This is Michael Snyder at Stanford, and I bet many in the audience have seen this, but these data show that there are 2 crests in multi-omics data at 44 and 60, where enormous changes in gene expression, metabolites, et cetera, are reflecting enormous changes in what Snyder says are related to chronological aging. The remarkable part about it that led to my interest is that the network analysis of all of these changes show that changes in males and females are actually quite similar to one another, and more similar than Snyder's group expected. And what that suggests is by subtracting from the overall overlap so that we can see the actual changes, we may be able to get at the multi-omics differences that actually occur in women and that we can actually attribute to reproductive aging. So I think we're about to disentangle this. So there's a way forward understanding that to test efficacy of aging delay strategies in the ovary, and then test whether delaying each of the menopausal transition and menopause has a causal upstream impact upon the chronological aging measures. And so I'm going to finish off. How am I doing at time? I apologize. I'll go. It goes very quickly when you're up here. So the example intervention is ovarian tissue cryopreservation in healthy women. I'll go fast. I apologize. The paradigm is usually that a woman's being treated for cancer. She'd be treated, have ovarian tissue collected and frozen prior to treatment that would otherwise damage her egg reserve. She'll recover and have the tissue transplanted back and resume her cycles and fertility. Instead, we used our model and applied it to what would happen if we did this in healthy women, and dealt with these variables circled as follows. And this interactive tool is available that shows, depending on the percent of ovarian cortex you move, 25% meaning half of one ovary, the percent that survived the procedure, and the age that you remove them, you can model how much delay in menopause you're likely to get. So this is just one example of a strategy you might use to delay menopause, practically speaking. I'll skip this. This is just example output. The contention is, again, that the young cycling ovary that can support regular cycles is geroprotective. This is testable and potentially highly impactful for life and health span. I will not trouble to read these. I'll just wrap up. But I will credit the collaborators and funding agencies, and thank you for your attention.
Thank you, Josh. Got the questions up there?
I'm sorry.
Thank you very much for your exciting lecture. Actually, you are looking at what we clinicians call the ovarian clock that lets the primordial follicle grow. And there is no doubt that once we know the the mechanism, will be able to prolong ovarian life. Because if you look at the, in Turner syndrome, at 20 weeks, they have the same amount of follicles. When they are born, it's 0, so the clock gets weird. And I'm giving a lecture tomorrow on the HRT treatments, but there is no doubt that the ovary itself is geroprotective, estrogen is geroprotective, and it shows that women who have irregular cycles, who have hormonal imbalances during reproductive life, are sicker and live less than women who have normal ovarian function right into menopause. So there is no doubt that this is the reason why women live longer, and I think that women are a type of something that we need to learn why they live longer. Not that men will take estradiol tomorrow, but if they do, they could also live longer.
I can finish.
One here.
I want to ask about the hormone replacement therapy. For example, if a woman enters menopause before the age of 45 or 40, premature menopause, if we give hormonal treatment, does it make her lifespan and health span increase?
It keeps symptoms away.
That's right.
It keeps the many of the consequences away, not all. And I am not aware of a systematic review of sort of lifespan after HRT that's convincing above baseline.
It does.
But I'm aware of studies.
I'll talk
Yeah.
about it tomorrow.
Yes, I'll defer to this gentleman.
Okay, thank you.
One more question here.
So in
And
your
then-
model, you start from assumption that ovarian follicles experience some sort of stress that is like obviously should be very different from the rest of the tissues which continue to function just fine or not so fine after menopause. So like, have you thought about like what is that specific stress?
At length, yes. And I can share data with you after this, but I can say short term that every marker of cellular or say DNA damage that we've looked at occur in follicles under untreated normal conditions in both the human ovary and in the mouse ovary.
One last over there.
So, thank you. So my question is, so is the basic process that causes the dissociation of the follicle is entry to the cell cycle?
Sorry.
Is entry to the cell cycle the process that causes the follicles to dissociate?
And begin to grow, yes.
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 And is that something that you try to target?
So I'm trying to think if others have shown there are not, other than I want to say no, so the answer is no. Deletions of cell cycle regulatory machinery, with one possible example I'd have to double check, have not been shown to regulate the rate of entry of follicles into the cell cycle. That's true, but there's one I'd have to check.
Thanks.
Yeah.
Thank you, Josh.